We call that Rxn for chemical reaction between chemical reactions and a calorimeter. A calorimeter. Okay, so we will use Q for heat for both the heat gain or released by the reaction and the calorimeter. So one Q will be the Q Rxn. The other Q will be the Q, that's just for simple called the calorimeter. So these two has same number but opposite sign. Okay? So you will first use the given information to calculate how much heat released by the chemical reaction. Okay? So the question tells us for every 1.00 gram of benzoic acid, it release some heat. So we use sort of the equivalency. Okay? Release, that means negative. So 26.38 kg of heat, and this come from this. So release this amount of heat, okay, from 1 gram. So we write out this equation. Okay? So this equation can be written as a fraction. We can use fraction to the conversions. So we get negative 26.38 kJ per 1.000 gram of benzoic acid. And next question, next step, you will take how much benzoic acid actually used. Okay, so tell you did not use 1 gram, you did not use 2 gram, you use 0.850 gram. Okay, so use 0.850 gram of the benzoic acid, and this fraction. So we can convert this gram of benzoic acid into how much kilojoules. So negative 26.38 kilojoules, then 1.000 gram of benzoic acid. Okay? And we can see the gram benzoic acid cancelled out, and we see how much kilojoules released by the chemical reaction. So that gives us negative 22.423 kJ. Okay? So again, we want to keep tracking the sig figs. So this one has 3 sig fig. Okay? So that's the least, because this has 4, this has 4. So we mark this 4 here. So we'll show this has 3 sig figs. Okay? And then, so this equals the Q Rxn. Okay? So we know the Q calorimeter equals negative Q reactions equals negative from the conversion, and then we have another negative from our number 22.423 kJ, and we underline this 4 to keep 3 sig figs. So therefore that become positive 22.423 kJ. Okay. Now we know there's another equation for the calorimeter. So Q calorimeter equals C times delta T. Okay. What is C? So C is the so-called heat capacity. That is the one you want to find out. So this is simply the heat capacity, not the specific heat capacity. So you just now just find out this number, because this number you already find out. So delta t, okay? So we know delta t equals Tf minus Ti. For this problem, the given Tf is 24.27 degrees Celsius. The given Ti is 22.01 degrees Celsius. So we do a subtraction, we get 2.26 degrees Celsius. Okay? So now we will plug this number for Q, plug this number for delta T, and then we will find out C. Okay, so 22.423 kJ equals C, you don't know, keep it right as unknown, and delta T is 2.26 degrees Celsius. Okay, so therefore 22.423 kJ divided by 2.26 Celsius equals C. Okay? And you divide, you find out, you find out what is C, right? So C will become, run into the, oh, we forgot to mark this, 4 has 3 sig fig, 3 sig fig, 3 sig fig, 3 sig fig, so therefore you find answer, the 3 sig fig, that become 9.92 kJ per Celsius equals C. So the answer, that means the multiple choice answers is B. And that's the answer for this question.